Morning. Today we are going to see about Kepler's law in the first topic in Unit 1. Kepler's law. Once you know about Kepler's law and Newton's law, students can able to understand the concepts of Kepler's law, understand the concepts of Newton law and geostationary orbits. The fundamental properties of orbit are summarized in Johnson-Kepler three laws of planetary motion. The three laws are Kepler first law, Kepler second law, Kepler third law. Kepler first law. The path followed by the satellite around the primary will be an ellipse. An ellipse with the focal point F1 and F2, semi-major axis A and semi-minor axis B. Then eccentric of the ellipse is given by E is equal to square root of A square minus B square by A, where A is the semi-major axis of the ellipse and B is the semi-minor axis of the ellipse. You can see the diagram where when 0 less than E less than 1, the orbit is elliptical. When E is equal to 0, the orb becomes circular. Kepler's second law. For equal time interval, a satellite will sweep out equal areas in the orbit plane which is focused on the band center. Now the two area A1 and A2 will be equal. The average velocity in each cases S1 and S2 meter per second. According to equal area of law, velocity S2 is less than velocity S1. Kepler's third law. The square of the periodic time of orbit is proportional to the cube of the mean distance between two bodies. This can be expressed as A cube is equal to mu by n square, where mean distance is equal to semi-major axis A. N is the periodic time of orbit in radian. Earth geocentric gravitational force and mu 3.98600 into 10 power 14 meter cube by second square. Newton's law. Sir Isaac Newton developed two laws of orbital mechanism from the Kepler's law, derived from Newton's law of universal gravitation, Newton's second law of motion. Newton's law of gravitation. The gravitational force of attraction between two bodies with the mass m and m, they directly proportional to the product of their masses and inversely proportional to the square of the distance between them. F is proportional to mass m and product of the mass m by square root of r square. So we can remove the constant F is equal to g m by r square. Newton's second law. The acceleration of the body is proportional to the force acting and inversely proportional to mass. A is proportional to F by A. F is the force, m is the mass of the body. Station keeping orbit control. The geostationary satellite kept in constant and correct orbital star. Therefore, in addition to controlling the attitude, the orbital position should be controlled. This is called station keeping. Reason. The reason for the slow drift of satellite from the orbit is equilateral elliptical of the Earth. Two types of operation being done for station keeping are east-west station keeping maneuvers, north-west station keeping maneuvers. East-west station keeping. Here the drift is opposed by the oppositely directed velocity component which is given to the satellite by using jets. These jets are operated once every 2 to 3 weeks. As a result, the satellite will remain in the original position until the jets are operated. Once again, the maneuvers are termed east-west keeping maneuvers. This is mainly done for drift in longitudinal. Longitudinal toleration limit for C band is 0.10. Longitudinal toleration limit KU band is 0.050. Northwest station. The geostationary satellite may move from the position latitude also. The main reason for this gravitational pull of sun and moon, the rate of change of inclination due to it will be 0.85 degree per year. This is not correct. The inclination would change from 0 degree to 14.67 degree in 26.6 years. To prevent the shift in inclination, some jets are used. These jets are operated to make the inclination 0 as well as halt. Geostationary orbit. Geostationary orbit is an orbit in which satellite appears to be stationary with respect to Earth. There is only one geostationary orbit. Center of orbit must coincide with the center of Earth. Conditional record. The satellite must travel eastwards at the same rotational speed as the Earth, which is constant. The orbit must be circular. The inclination of the orbit must be 0. Geostationary height. Geostationary height is the distance between the Earth and geostationary orbit. It is found that HGSO is equal to AGSO minus AE, where AE is the equatorial radius of the Earth, ASO is the radius of the orbit. To find the radius of the orbit for a circular orbit, the semi-major axis is equal to radius. Hence, by using Kepler's third law, the radius can be written as mu p by 4 pi r square, where Earth geometric gravitational constant P is the period of geostationary time taken to complete one rotation with the NS axis. P is equal to 23 hours 56.4 minutes. Substituting the value will be AGSO is 42,640 kilometers. Now the geostationary height from the equation GSO is equal to AGSO minus AE. You will get 36 kilometers. Types. All the non-geostationary orbit can be grouped into low Earth orbit, polar orbit and medium Earth orbit. Assessment question. Kepler third law that the path followed by uptaking circle. The path followed by the circle around the primary will be an ellipse. The path followed by the circle around the primary will be sphere, or none of the above. Second question. The following comes using the service of signal transmission, information, broadcasting and other. From this you can understand the basic. Then we are going to see about non-geostationary orbit. Thank you.